So in today's video we're going to look at manipulating formulae. So manipulating formulae is just another way of saying we're going to rearrange an equation that we've been given. So in order to know when we do this, you need to know really two ways that it can be asked. So the first way is either going to say write or find or express x in terms of y. So that's the in terms of, and we have seen that before. In particular, you may have seen it in area and volume. When you work with either the circle or a cylinder, you might have been asked to give your answer in terms of pi, which meant that there was pi in your answer. So the second way this can be asked is to make x the subject of the formula or the subject of the equation. So both of those are actually asking the same thing. They want you to write x equals and then something with a y in it. Okay, so when you see either of those, you're thinking straight away, I'm going to be rearranging or manipulating the equation or the formula. So let's start with the first example. So the first one we've been asked is express x in terms of the other variables. Now, in this example, we only have y as another variable, but that's absolutely fine. So the goal is to get x on its own. Now, in this case, that's not too difficult. Straight away, though, we should see that this piece here is stopping the x being on its own. So let's get rid of this first. Okay, so we're going to move that across the equals. So when we bring a minus 2y across the equals, we're going to get a plus 2y. Okay, and then here, it's important to note that when we have a 3x, what we're dealing with is 3 multiplied by x. So in order to get rid of that 3, we need to divide both sides by 3. Okay, so let's divide this side by 3 and this side by 3. These effectively cancel. So on this side, I'm just left with an x, and I'm left with 4 plus 2y over 3. Now, there's no need to clean that up further. That's absolutely fine. We have expressed x and in terms of the other variables. So again, we're just getting the x on its own. So let's look at another example. This example is going to be slightly more difficult because the fact that we want to find t in terms of x, so it's going to be t equals, so we want to get t on its own, and if you can see, we actually have a t here above the line and 3t here below the line. So because that t appears more than once, it makes our job a little bit more difficult, but still doable. Okay, so like in any equation that we have with fractions, we're going to aim to get rid of the fraction. So let's rewrite my formula here first, or my equation. And we should be all familiar with how to get rid of fractions. So the method to get rid of fractions is we multiply both sides by what's at the bottom of the fraction. And on this side here, I'm going to multiply by 3t plus 1. So here they cancel. So what I'm left with is 3t plus 1 by x equals t plus 4. So I need to multiply out my bracket now. So I get 3tx plus x equals t plus 4. Now remember, I'm trying to find t, and I'm just going to highlight here so we can remember. I'm trying to find t in terms of x. So I have a t here and I have a t here. So what I want to do is I want to bring them at least to the same side. So let's have a 3tx here. I'm going to bring that t across the equals. Since that's a plus t, it'll become a minus t. And that equals 4. And let's bring this x back across this side. So it was a plus x, so it's going to be a minus x. Okay, so now we have to use a factorization. We're going to use highest common factor because if we take a look here, 3tx minus t, what's common? And that should be a t. And that leaves me with 3x minus 1. Now be careful, we've taken out a t from minus t and we're left with minus 1. The double check is t by minus 1 will give me minus t. And that equals 4 minus x. So like in the previous question, I'm just going to rewrite this up here so we have a bit more space. We now have the t multiplied by something. In order to get rid of that, I'm going to divide both sides by 3x minus 1, which on the left hand side, that will cancel, leaving us with t equals 4 minus x all over 3x minus 1. So I suppose what's really important here is to remember this step here, which is the factorization. So factorization. It's so important that you remember to do that step when it appears more than once in the initial equation or the initial formula. Other than that, it's exactly the same. So let's move on to another example. So in this case, we want to express c. So I'm just going to highlight that here, just so we remember what we're looking for. So we want to get c in terms of the other variables. So there's a good few other variables here. We have a, we have b, and we have d. So we want to get c on its own. Now straight away we can see that there's a square root. So that's the first thing we're going to have to deal with. And how we're going to deal with that, we're going to have to square both sides of the equation. Because remember, the square and the square root, they're the opposites of each other. So if I want to get rid of a square root, in order to do that, I will square it. So I'm left with d squared equals a minus b over ac, because what actually happens effectively is the square root and that square, they cancel with each other. So now I have my c here underneath the line. So to get rid of my fractions, I multiply both sides by what's on the bottom of the fraction. We have some cancellation here. So I'm left with ac by d squared equals a minus b. So this is ACD squared equals A minus B. I just want this C. Remember, these letters written together, they're actually multiplied. So I can divide both sides by AD squared. And here, these cancel. And what I'm left with is C equals A minus B over AD squared. So I've now expressed c in terms of my other variables. Okay, so example 4. So this is using something that's familiar to us, or these should be familiar to us, and it's the volume and the surface area of a cylinder. So both of these formula are given in your log tables, but this particular question, it's not asking you to use them, it's asking you to rearrange them. So the volume of a cylinder is given by V is equal to pi r squared h. Find the radius or in terms of V and h. So we're trying to get or on its own. So let's start with what we have. So V is equal to pi r squared h. So straight away we can see that there's an r squared and it's being multiplied by a pi and a h. So let's divide both sides by pi and h. Okay, so the pi's cancel, h cancels, so we're left with v over pi h equals r squared. Now, in the previous example, we had a square root, which we got rid of using a square. This time, we're going to actually put a square root on both sides. Okay, so we'll put a square root on both sides, because the square root of r squared will just leave me r. So I'm left with the square root of v over pi h is equal to r. And that's our answer. So remember that every operation in maths, they come with a partner, they come in pairs. So adding and subtraction, one is the opposite of the other. Multiplying and dividing, one is the opposite of each other. And we have squaring and square roots. Okay, so let's look at the next part of this question then. So they've told us that the surface area is given as A equals 2 pi r h. Find the radius in terms of A and h. So let's start with what we've been given, 2 pi r h. We want to get that r on its own, so we can divide both sides by 2 pi h. 2 pi h. So those 2's cancel, pi's cancel, and h's cancel. So A over 2 pi h is equal to r. Okay, so that was quite straightforward. So now that they want to show, so now we're looking at part C, and show that A squared is equal to 4 pi h v. Okay, so the hence here is important. It means using our previous parts. So if you look here, we have effectively at the first step got or equals the square root of v over pi h. Here we have or equals a over 2 pi h. So although we have two different expressions for or two different equations of or, they are equal. So let's those equal to each other. Basically what we're going to do is we're going to say or is equal to or. We're going to have the square root of v over pi h is equal to a over 2 pi h. Now, the first thing we're going to do is get rid of that square root, so we can square both sides. So square and the square root cancel, leaving us with just v over pi h is equal to, and in order to square a fraction, we square the top and we square the bottom. So we have 4 pi squared h squared. Okay, so I'm trying to get a on its own. So let's try get rid of the fraction, and in particular this fraction here. So we'll multiply both sides by 4 pi squared h squared. We'll do the same on this side here, 4 pi squared h squared. What happens then is this cancels here, and you might notice here we've a pi that can cancel with one of the pi's and a h that cancels with one of the h's. So we're left then with 4 pi h by v is equal to a squared. So if we just rearrange that so it matches what we've been asked, a squared is equal to 4 pi h v, and that's exactly what we were asked. Okay, so this is an exam question which uses the idea of the manipulation of formulae. So the time taken in seconds for a satellite to complete an orbit of the Earth is given by the formula t is equal to the square root of 4 pi squared or to the power of 3 over gm. And they give us some of these letters, what they stand for. So or is the radius of the rotation from the centre of the Earth. G is the universal gravitational constant. M is the mass of the Earth. So the first part of this is express the radius of rotation or in terms of the other variables. So this is exactly what we have been doing. So let's take a look. So we start with t equals the square root of 4 pi squared or cubed over gm. So the first thing we want to do is we want to get rid of that square root. So we're going to square both sides. So we're left then with t squared is equal to 4 pi squared or cubed over gm. Great. Now we want to get rid of that fraction, so let's multiply both sides by gm. Now these two here cancel, which leave us with gm t squared is equal to 4 pi squared or cubed. Now we want or on its own, so we're going to divide both sides by 4 pi squared. And what happens here is the 4's cancel and the pi squareds cancel. What that leaves us with is or cubed is equal to gm t squared all over 4 pi squared. So all I've done is I've just written it the opposite way around here. Now, when we want to get rid of a square, we use the square root. Because we have a power of 3 now, or a cube, we're going to use what's called a cubed root. It looks like a square root, but we write a little 3 there. So it's asking the question, what number multiplied by itself and by itself again will give me this number here. So I'm left with the cubed root of or cubed is just or, and that is all equal to the cubed root of g m t squared over 4 pi squared. So we've now written the radius of rotation or in terms of the other variables. So the next part of that question is, the International Space Centre ISS orbits the Earth once every 91 minutes. Given that the value of g is 6.67 by 10 to the power of minus 11 and the mass of the Earth is 6.4 by 10 to the power of 24, find the radius of rotation of the ISS correct to the nearest meter. So what they've given us is 91 minutes. Okay, so that's your time, but be careful because in this formula, t is the time taken in seconds. So the first thing you'll have to do is convert 91 minutes to seconds. So let's do that. So 91 minutes is going to be 91 by 60 seconds. So that gives me 5,460 seconds. So we're going to need that. That's t. They also gave us then g. So they told us g is equal to 6.67 by 10 to the minus 11. They gave us the mass of the Earth, which is m, as 6.4 by 10 to the power of 24. And if we look at our formula here, to calculate or, we need our g, which we have, m, which we have, t, which we have, and then it's 4 pi squared. So let's write this all out. So or is equal to the cubed root of 6.67 by 10 minus 11, 6.4 by 10 to the power of 24, by 5,460 squared, and that's all divided by 4 pi squared, and you can put that directly into your calculator. So I'm going to leave the cubed root out of that just for the minute, and working out what's here should work out at 3.224 by 10 to the power of 20. So or is equal to 6,856,625.858, and they've asked for that to be to the nearest meter, so we're going to round up. So we've got 6,856,626 meters. So now just to look at part 3, and to give us some space, I've just cleared off the screen here. So it's asking us to find the height the ISS is above the surface of the Earth, given that the radius of the Earth is 6,371 kilometers. Okay, so what's actually happening, and you can kind of see it here in this diagram, is we've come along and we've calculated this height here, okay? But they want to know just this bit here, okay? So they just want that bit that I've highlighted in yellow. So we know from the previous part, so I'll just write it here for us. So the radius of rotation, which was r, and that equaled 6,856,626 meters. Okay, so we know the whole bit here is 6,856,662 meters. They've just told us that this piece here is 6,371 kilometers. So the first thing we need to do is we need to convert the radius of the Earth into meters, because we've been working in meters, so that's 6,371 kilometers. So 6,371 by 1,000, so there's 1,000 kilometers in a meter. That gives us 6,371,000 meters. So then, in order to find the height above the Earth, above the surface of the Earth, we're going to have 6,856,626 minus, so we're going to subtract them, 6,371,000, and when we take them away, we get 485,626 meters. And if we want, then we can convert that to kilometers, because they did give us kilometers in this part of the question. So that could work out to 486 kilometers. Okay, so you've both answers there, so you'll be covered. So the first part of that was the manipulation of formulae, and the other two parts, well, the first one was just subbing in, and then the second part was really just taking away two numbers, but it was trying to see, I suppose it was more problem solving, in the sense that you had to figure out exactly what you had to do to find the height above the surface of the Earth.